for tonight, let's go ahead and go back to easy, medium, hard. In other words, I don't think it really benefits us that much to do nothing but hard, and I think it benefits us a lot to do easy and medium. Okay. All right. So let's do number 1. Here, let me blow it up a little bit. Is this going to be a hard one or an easy one? Exactly. You're guessing exactly right. It looks hard because it is 8 sentences or 8 lines of print. That makes it look hard, but you know it's easy because it's the first one. So let's look at it. Go ahead and read it. What do you think is the answer? A more expensive brand of paint. Well, is that going to be affected by the number of walls? About the length of each wall in feet. The height in feet. So what's the only thing left? Yeah, that's the only thing left. So it's got to be K. All right. Let's scroll down and take a look at number 3. Oh, hold on. There we go. Or not number 3. I'm sorry, number 2. What's our first job on number 2? What's the first thing we need to do? No. Don't try to do it the easy way. Try to do it the regular way. Hold on a second. What is going on here? That's interesting. I got a totally new thing that showed up on my computer. Snip and sketch. Can't close it out. What is going on here? Can you see it on my screen? It's like when I try to close it, it won't close. Interesting. Okay, let me open it up. So, not sure what's going on, but so far it won't hurt us. If 3r equals 18, what is r equal to? Okay, now what's 6r plus 3 equal to? What's r equal to? Okay, good. In other words, when you see an easy problem, think easy solution. This is not hard. You just have to know that it's an easy problem. Don't psych yourself out into thinking that it's a hard problem. Okay, number 3 is really just about nomenclature. In other words, do you know what a to the 2/3 means? Now look at the answers and take a guess. Hold on. Okay, go ahead. The only thing you have to remember is the bottom, the denominator means what? Is that the root or the power? It's the root. No, the denominator is always the root. In other words, a to the 1/2 equals square root of a. Okay? A to the 1/3 equals cube root of a. So what's a to the 2/3 going to equal? Third root. Perfect. Number D. Yeah. Okay. This is very bizarre. What's going on with my computer? Never seen this problem before. It's not letting me close out a page, which prevents me from scrolling to the next page. What could be going on here? Actually, it worked last time. It just took forever, and that appears to be what's going on right now. Just taking forever for it to work. Yeah, finally did. Alright, well, I'll know before I do that again, I guess. My number 4. Instead of guessing, pick a number for x. Okay. So if x is 60, and you can truly pick any number, and the key to think about here, Brandon, is the fact that x is in the question and x is in every single answer. Whenever you have that situation, you can always make up whatever x you want. Okay? If 30 states joined from 76 to 1849, and X states joined between 1850 and 1900. Okay, so you picked an X of 60. How many states joined prior? How many states joined between 1776 and 1849? Oh, it says it's twice. Yeah. Well, what did you say for X? You said 30 or 60? I thought you said 60. Okay. So what would it have to be if it's twice? And don't mistake this for reality. It doesn't matter that there's only 50 states in the United States. We're making up numbers, okay? So if you said that x is 60, then how many states joined? See, they tell us actually that 30 states joined between 1776 and 1849. So what is x? Just think about the problem for a moment. The number of states that joined the United States in the first 70 years is twice the number of states that joined between 1850 and 1900. And then they're telling us that 30 states joined between 1776 and 1849. So how many states joined between 1850 and 1900? Just think about that for a moment. First part is twice the second part. And they're telling you that the first part was 30. So what's the second part? Okay, good. Now, let's look at all those answers. Which one says x is equal to 15? Just solve them. No, x is equal to 60 in C. Solve each equation. Which one gives you x equals 15, which we know that to be the answer? Okay, let's look at A. What's x equal to in A? Solve for x for A. No? Solve for x. I want you to be able to do a simple algebraic equation here. No point in going any further if you can't do A, B, C, and D. Solve for x in A. What do you get? Okay, I want you to solve for x in A. That's the only thing I want you to think about. Forget the question, just solve for x. How do you solve for x in A? What do? Right now you got 30 times x equals 2. So how do you solve for x? By, give me the whole solution. Okay, what do you get? That's 1/15. That's not 15, that's 1/15. Okay, so A isn't correct. Now solve for x in B. Yes. In other words, whichever one gives you 15, that's the answer. So you have to be able to solve each of those 4 equations. They're very simple equations to solve. What do you get for x when you solve C? What do you have to get rid of when you're solving for x with answer C? Okay, so how do you get rid of that 2? Okay, that's pretty easy. What's x equal to? Okay, and in D, what is x equal to? Yeah, so we know it's not D for sure. because it's not a negative number. We know it's not C, because we know the answer is 15. So the only one that's 15 there is B. So that's the way to solve this problem. It's just to know what the answer is, knowing that if 30 states joined in the first part of our country, then 15 states must have joined in that 50-year period. So we have to find where X is 15. Number 5. Tell me how you're going to solve number 5. I'm going to try this one more time here. No, I don't like it. Yeah, I really don't like it. What the heck did Microsoft do? Alright, I can write on it. It's getting rid of it that's going to be the problem. So if 5x equals 15 over x plus 20, what is x over 5 equal to? It's a little harder equation to solve, but that's all it is an equation with one variable. So you really need to solve for x to solve this problem. Okay, so if 5 over x equals 15 over x plus 20, what's the first thing I do when I try to solve an equation? Get rid of what? Okay, I got two denominators. What can I do? Okay, give me the next line. It's not 5x plus 20. Yes. In other words, that 5 has to multiply everything there, not just the x. If I'm going to cross multiply, I got to multiply the whole denominator. Okay, so now I got that. Now solve for x. It's the next step. Okay, give me the next line. Okay. If x equals 10, what's x over 5 equal? There you go. Why would this take so long to go away? Could possibly be going on. It's going to change everything for me. This is horrible. It really is. They've changed the program, and now it's got like a 30-second delay to go away, and I need it to go away before I can go to the next problem. That is bad. Well, hopefully I'll be able to figure this out before our next session, but until then, I'm just going to have to live with it, I guess. Yeah, it finally went away. Took about 30 seconds. Alright, let's look at number 6. Now we know they're going to get a little bit harder after the first 5. Everything we've dealt with so far is pretty easy. Number 6. First of all, let's talk about systems of equations. How are you going to solve this system of equations? Or, okay, which one are we going to use here? I think so. In other words, whenever you see both equations are in standard format, think elimination. Can you eliminate a variable by just adding or subtracting these two equations? So what do you got to do first? Both of them. So what do I multiply at the top? Well, let's call this equation 1. Let's call that equation 2. So what are you going to do to equation 1? By okay, give me what's the result. Uh-uh. 6y 28. Okay, now what am I going to do to the second equation? Good. Tell me what I get. Good. Now what? Hold on. Hold on. You don't just get rid of stuff in math. You can add equations or you can subtract equations. That's all you can do. So what are you going to do here? How do you eliminate one of the variables? That's the question. Okay. I add the two equations. It's important that you understand that's what you're doing, is you're adding the two equations. I'm going to put a big plus sign in there. What do you get for an answer? Yep. Perfect. What's x equal to? Okay. Now notice they've tricked this up a little bit. They're not asking us what x is. They're asking us what x minus y is. So we have to solve for y. Now, so of the original two, and it's almost always going to be easier if you use the original, which one are you going to use to solve for y? That's the next question you have to answer. So which equation are you going to use to solve for y? Which one has the smallest numbers? That's the one we're going to use then. So it's 3 times 2, because we know what x is, it's 2, minus 2y equals minus 6. Now, tell me how to solve that. Be very careful here. Make sure you don't do what exactly. It's really, really easy to make the mistake you just made. You don't want to do it. That's because you're looking at how to make that 0. You shouldn't be doing that. You should be looking at how to get rid of that 6. Well, what do we have to do to get rid of that 6? We've got to subtract it. So what's the next line? Next line. Okay, and now what is x minus y equal to? Good. There you go. Now I gotta wait some length of time before this thing closes out. Did we get cut off? Brandon, are you there? Brandon? Brandon? Oh, no problem. I was just trying to figure out what had happened. I'm already trying to figure out what's going on with my snip and sketch. And I can't figure out what's going on with it. It just takes like a minute to close out. God, I can't even use it like this. I'm going to have to figure out a different way to do this. Wow, there we go. Okay. I can get through this session. All right, let's look at number 7. For a second, might have a different way of doing this. Let me try something, Brandon. Let's see, we're on number 7. I want to do this. Let me see if this helps a little bit. Well, right off the get-go, it doesn't. That's the wrong file. It's not the file I want. Heck. Oh. I guess I get it. I'm going to have to figure this out, and I don't want to do it in real time. Let's just go through and do as good as we can. Alright, hold on a second. Let me blow that up a little bit. So number 7. First of all, let's talk about functions. Okay, this is kind of a hard problem for being number 7. If you have a function, I'm going to draw it way over here on the right because I'm going to need the room. Let me put some points on that graph. What's the first point that I can put on there? It's another word for f of x. Y. Y is the same thing as f of x. Okay? So when you see a table that has an x and an f of x, it's the same thing as if they gave you a table of x and it was called x and y. Okay? So give me the very first point that I can put on this graph. What's the x-coordinate? What's the y-coordinate? What's the next point I can put on there? What's the next point I can put on there? And the final point. Okay. So that's what that graph looks like. Does that help us understand factors? Well, this represents a polynomial, that graph. And the question is it divisible by one of these factors? Well, what would have to be true if it was divisible by one of those factors? It's a really tough problem. I'm not sure, to be honest. Which of the following must be a factor of f and of x? Well, whatever that function is it divisible by x minus 2? And how do we tell? Or is it divisible by x minus 3, or x minus 4, or x minus 5? You know what? I'm going to table this problem. Come back to it next time we meet. And I'm amazed. This is question number 7. This should be question number 17. Run into this question before, and I remember I had to think about it for 30 minutes before it came to me what the answer was. It's not coming to me right now, so I'm just going to set it aside for the moment. Let's go to another one. But first of all, I got to get rid of this. Wow. I wonder if I push new. No, it doesn't do anything. Actually, it does it, but it takes its sweet time. Maybe it actually did do it. All right, let's look at number 8. Notice the form of the equation. What form is that in? It says y equals kx plus 4. Of all your forms of a straight line, which is what that is, because it's only got an x, it doesn't have an x squared. It doesn't have a square root of x. So when you have a linear equation that's just got x to the 1, that's a straight line. What's the normal equation of a straight line that you've learned? Okay, well this is close to that. M is k and b is 4, right? Right? Okay, so they're asking us what is the slope? Well, what is the slope? If I solve that equation on the left for m, what do you get? Just solve that equation for m. It's easy enough. You don't have any parentheses. You don't have any denominators. What's the first thing you're going to do? You got to get rid of the x and you got to get rid of the b. So which one do you get rid of first? No. Get rid of whatever's being added or subtracted. Right now, B is being added. So I'm going to get rid of the B by subtracting it. Okay. Now remember, I'm solving for M. What do I do next? Okay, what do we have to get rid of if I'm solving for M? Okay, what's the X currently doing? It's multiplying, dividing, added, or subtracted. Okay, so what do I have to do to get rid of it? Okay, so I got to divide both sides by X. And now I have M equals Y minus B over X. Well, that's close to one of the answers. And what they tell you is that C and D are a point in that equation. So I can substitute C for X and D for Y. Okay? Because I know that they're telling me that it contains the point C comma D. Well, C is the X coordinate, D is the Y coordinate, right? So in that case, the slope is not Y minus B over X, it's D minus B over X, which is C. So I'm taking this part right here, see where I'm circling? And I'm substituting C for X and D for Y. All right. The problem is that that answer is not on there. Because I know what B is. What's B? Okay, so it's really D minus 4 over C. And that answer is on there. So, this is actually another really tough problem. This is not an easy problem, even though it's number 8. It requires that you be able to solve an equation, which we had to do to get M. But then once we get M is equal to Y minus B over X, we have to know that because the line contains the point C comma D, you can substitute C for X and D for Y. And 4 for B, because you know B is 4 from that. So it really requires quite a bit of logic to get to the solution here. A lot more logic than it should require for problem number 8. But that's okay. I mean, I'm not going to judge them on the difficulty of questions. But the last two have definitely seemed a little harder than they normally would seem. I'm trying to close it out. It's just taking a while. I'm going to have to live with this until I can figure out how to solve this problem. Gosh, can't even imagine what's going on. This feature of Windows that allows me to write using my drawing tablet has totally changed. Now it's okay. Now you'll notice that hold on, before you go to number 9, let's see. I'm going to pick and choose here, especially since of my writing difficulties here. Let's see, we have 15 minutes. Yeah, let's definitely do number, yeah. Let's look at number 11. You don't need to see the top. I only need to see that much of it. I'm going to go ahead and do this one more time, which means it'll take a minute to exit once I'm done. Okay, number 11 is a geometry problem. So we need to review our geometry rules. Okay. Now let's look at that picture. Tell me which angles are equal one another. Without reading any of the question, just look at the picture and tell me. No? No? What if I had this? Tell me which angles are equal to one another on the left. Vertical angles are equal. So which angles are equal? Yeah, 1 and 3 are equal and 2 and 4 are equal. Okay? So, y is equal to u. Correct? That's one set of vertical angles that I have. And I can tell also that another set of vertical angles is x plus w has to equal what? Based on vertical angles only. Yeah, exactly. Z plus t. I use the double line because that's a different angle. So I know y equals u because of vertical angles, and I know that x plus w equals z plus t. Now what else do I know? If I eliminate angle, or if I eliminate line L from the picture, what can I say about x? So here's what I've got. First of all, I got y equals u. Okay. I got x plus w equals z plus t. What else can you tell me about that picture? What about x and t? Eliminate line L. Now you still have angle x and angle t, right? The only thing you have is you have that and you have that. That's m. That's k. Oh, that's x. That's t. Are they equal? Yeah, they are. They're vertical angles. So x equals t. Okay. So, in other words, when you have a problem like this, you try to figure out what's equal to what. Okay, how about w and z? Are they vertical angles? Yeah, they are. So W has to equal Z. What other vertical angles do I have there? Here's the three that we've identified. Y equals U, X equals T, because it's vertical angles, and W equals Z, because it's vertical angles. Okay, in order to figure out those vertical angles, you have to kind of eliminate one of the other lines from your mind. But you can tell that W equals Z because that and that, if I'm looking at just these two lines right here, those are vertical angles, right? So that's what you want to do on these problems, is be able to eliminate a third line so that you can see in your brain where the vertical angles are. Okay? So, we've done that with those four equations. I could also say x plus y plus z equals what? X plus y plus z, in other words, this angle right there, equals what? Equals the bottom, w plus u plus t. In other words, the top three angles are 180 degrees, right? X plus y plus z, that's 180. And the bottom three angles, w plus u plus t, is 180. So I know that relationship is true also. But let's take one other piece of information that they've given us. X plus y equals u plus w. So let's write that in. X plus y equals u plus w. Okay. Well, I know that y equals u, right? So what does that mean about x and w? No, they do. Well, first of all, let's go from this equation line. We got a lot of equations we're looking at. So let's just first of all start with the fact that y equals u. If y equals u, what is true? Based on y being equal to u, what's the relationship between x and w? Let me write it right in there. I'm going to put, instead of y, I'm going to write u, because they're equal. Okay? Now solve that equation. What's x equal to? How do you solve that equation? You got x plus u equals u plus w. What can you do immediately? Look at this equation right here. X plus u equals u plus w. What can you do to that equation? Can you get rid of the u? How? Okay, what are you left with? When you subtract u from both sides of the equation, what do you get? Yeah. Okay, now I got a lot of things here. I got x equals w and I got w equals z. So first of all, what is x equal to in terms of z? Yeah, x equals w, and w equals z, so what's x equal to? Here, let me write it up here. X equals w, and w equals z, so what's x equal to? Use substitution. Yeah, exactly. And now, x equals z. That's number one. So that's true. Right? Okay. Now, is y equal to w? Well, y was equal to u. And u, we don't know what u is equal to. U is equal to y only. So I don't know that I can say y equals w. Hold on for a second. Let me think about this. Well, for the moment, let's table that. We don't know if y equals w or not. I know x equals w. I know y equals u. I know w equals z, but that doesn't tell me that y equals w. Let's look at the third one. Z equals t. Wow. Well, we know x equals z. We know that's true, which means t equals z, right? In other words, I can substitute. If x equals z, then here I know that x equals t, so I'm going to substitute t for x. I get t equals z. Well, that's right there. There's t equals z. So for the moment, the only two that I know to be true are those two. I do not believe we can prove that y equals w. And if we kind of look at it, if we look at the picture, we can figure out that y is not necessarily going to be equal to w. If you take line L and you rotate it just a fraction to the right, you change the relationship between y and w, right? And that's what's going to tell you that we cannot prove that y equals w. We just can't. And so I don't think that that is true. All right. You know what? These problems are way harder than we need. Let me think for a second here. Yeah, we only got 2 or 3 minutes. Let's just go ahead and continue on here. What I'm going to do next time is we're going to take test 4 and start from the beginning again, so that we can focus on easy and medium problems, which is what I'm looking for. I'm not looking for hard problems. 10 is not. 10 is hard also. Boy, it's like this thing changed instantly. Let's look at number 10, just because we only have a minute or two left. I'll go ahead and put up my drawing thing here. So 10 tells you that you have a parabola whose equation is x minus 11 squared. Okay? Now, we know what parabolas look like, right? If it said y equal x squared, it would be this. It would be the vertex at the origin, and it would look like a normal parabola. So if you think about transformations, what's that 11 going to do? No, not down. It's inside the function. The elementary function is y equal x squared. It's actually going to go right by 11 units. So it's going to have its vertex over there, but it's going to be exactly the same shape. Okay? Now, the gray line is the equation that we're interested in right there. And it says that when you intersect it with the equation y equals 25, well, what's y equals 25 look like? Y equals a number is a horizontal line. Right like that. Okay? Whenever you have y equals a number, you're talking about a horizontal line that goes through the y-axis at 25. Whenever you have x equals a number, you're talking about a vertical line. Okay? They want to know what the length of that is, right there. So in order to figure that out, we have to figure out, well, where is y equal to 25? So if I substitute 25 in for that, and I take the square root of both sides, I get plus or minus 5, that's the square root of 25, equals x minus 11, that's the square root of our function. And then you get x equals either 16 or 6. Okay, you with me? So if this point comes at 6 and this point comes at 16, what's the length of that line between A and B? This is A, that's B. Yeah, it's that simple. I mean, it's not simple, it's complicated, but it's that simple. In other words, figuring out the length of that line is easy once you know the x-coordinates. It's a horizontal line, so there's no slope to it. So it's just going to be the difference in the x-coordinates, which is 10. All right. That's number 10. I don't know. We'll start from there next or not. I gotta do some research here. Okay. I'll talk to you next time. Okay.